to see you. This is special because I live in Austin. Victor and I, he's here from Barcelona. We travel all over the world to give talks together. But right now I'm home, and that feels nice. Come to the local Kubernetes meetup, and I'll see you there sometimes. All right, here we go. So welcome to Choose Your Own Adventure, the dignified pursuit of a developer platform. Meet Hero. Hero is application source code on a developer's laptop. Hero longs to be a real application running in production, serving end users, and we're going to help Hero along the way. So our job is to help Hero navigate hundreds of CNCF projects, choose which ones to use, integrate with them with one another so Hero can live their dream. So I'm Whitney, this is Victor. Together we host a streaming show called You Choose, where each episode represents a different system design choice. Then we gather all the relevant CNCF that could do that thing, and we invite maintainers from each technology to each give only a 5-minute presentation. We have a gong, we cut them off, it's joyful. So then we ask the community to vote, and whichever one y'all vote, we build into an ongoing demo. And we're gonna do some live voting and live building today as part of our talk. But the important thing to know is we scope everything to CNCF. So in our show so far, these are all the system design choices we've made for our application to get deployed in production and to run securely and with observability. So this is a lot. This is too much for one application and one application team to have to worry about. And that's why we have the rise of platform engineering. So a platform is an integrated capabilities that are organization specific that are self-service to developers. And so with a platform, we have experts who really know their stuff. They know they know their one thing, and they know it really deeply. So you might have a Kubernetes expert, a database expert, a messaging expert, whatever else. And then we have our developers. Our developers just want to use those things. So they don't want to have to make it themselves. They don't want to have to manage some sort of managed service. And they don't want to have to put in a ticket and wait a long time. So they want stuff from the experts, and it's the platform and the platform engineers that help them get what they need. And so our job as platform engineers is to make that platform. So, and here's this, we're gonna go quickly. So what's cool about it is that whatever you make for your developers is gonna be specific to your organization and follow your organization best practices in security. So, we have like 20 minutes left in this presentation. Let's build a platform together. So everyone get out your phones. Please scan this QR code. We're gonna do live votes as part of this. And we're gonna go through 4 system design choices. We're going to create an API and manage state. We're going to add cluster level policy. We're going to execute one-time tasks. We're going to build pipeline. And we're going to add a graphical user interface. So we're going to go through these 4 system design choices. You're going to vote on which technology to choose, and whatever you vote is what Victor's going to build into an ongoing demo. So let's do this thing and get to production. So first of all, let's talk about APIs and state management in the context of platform building. We're going to talk about crossplane versus Kubevela. So why do we need API and state management? I'm actually going to be even more specific. We need Kubernetes APIs, and we're going to manage state with Kubernetes as part of our platform. So why do we need Kubernetes at all? First of all, Kubernetes is the industry standard. I think maybe since we're all at Kubernetes community days together, I don't have to try to convince you of that, but everybody's doing it, and therefore you should do it too, which is actually good logic in software, but maybe not in the rest of your life. You know, you do you. Another reason is you can leverage the Kubernetes ecosystem, but really the big reason is we're going to take advantage of that Kubernetes synchronization loop so we can define anything, including stuff outside of the cluster, in a declarative way and trust Kubernetes to sync that for us. So here we go. Our developers want a cluster this time, but we don't have any APIs running in our cluster yet. So as platform engineers, the first thing we're going to do is talk to an infrastructure expert who already knows more about building a cluster than we've forgotten more than we'll ever know. So we need to work with her and come up with a declarative way of how we want clusters to look at our organization. And then we're going to build that into an API. We're going to codify that knowledge, and then we're going to run that API. Well, we're going to codify it with a tool like Cluster API or a tool like Crossplane. And then we're going to run that in our Kubernetes management cluster. So now when our developers apply a YAML and say they want a cluster in a self-service way, that tool is going to kick in and it's going to reconcile our desired state now with actual state, which is a separate, a Google cluster in this case, running completely outside of our Kubernetes management cluster. So we're going to talk, and then other reasons to use APIs in general, you can wrap APIs in other interfaces. So you can use a GUI, a web portal, you can use a CLI. Your application developers can access your capability at whatever point in the workflow they need, but there's an API underscoring it all. And then the second reason APIs are great is because you can use them as building blocks. So you have an API for your Kubernetes cluster, an API for a database, an API that actually deploys your application. And eventually, as your platform matures, you can put all those together into one more complex capability that deploys a cluster, integrates it with a database and your application all behind one API call. So let's finally talk about the tools. Crossplane as an API builder. So what Crossplane is it's a way to take anything, any API on the planet and bring it into Kubernetes so you can manage it as a Kubernetes API and take advantage of that synchronization loop. So taking advantage of the synchronization loop is a big deal. Also, we can compose lots of different APIs into one API, like I just discussed. And then the third cool thing with Crossplane is that you can then present that API to your developer in a way that abstracts away all the complex details, and the developer just has a few choices on what's relevant to them. Kubevela is a way to define an application and deploy that application, and you do that with Kubernetes API. Your application doesn't actually have to be running in Kubernetes, but you can use it gives you abstractions to be able to use Kubernetes APIs to be able to define and deploy your application. So it is similar to Crossplane, but scoped only to applications. And it's awesome because it has great community support, as does Crossplane. I'd say the big difference besides the scope is that Crossplane, since it does everything, I keep pointing at him because he works at a company with that does Crossplane. Crossplane does, because you can do about anything with it, that means it's freaking complex. Like, there's so much. It's harder to use. And then Kubevela, since it's more scoped, it is easier to use, but it does less stuff, which is a theme you see often in software. So finally, let's vote and see what Viktor's going to build for us. Woohoo.
We need to do voting fast.
Voting.
Time. Go, 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 go. 5, 4, 3, 2, 1. Crossplane. Okay. Cool.
Crossplane. Yeah.
I don't know what you did. Cool. Okay, let's do it. Do you see this? Is this big enough? Good. Okay.
Can you hear Viktor?
Huh?
You need to get closer to your.
I don't know how to do that. Fuck. Okay. Yeah, something like that. Okay, let me set it up. Don't do that. Okay, I'm going to set up Crossplane. Normally I would do this live with the real commands, but I don't have time today, so let's just go for it. So Crossplane beta trace. So if you take a look at what I did, where is it? GitHub claim CNCF demo up. There we go. Right. Before I started this session, I already created the first instance of it. That basically created the repository with everything I will need over there, and it's managing that repository. But and that repository, I already cloned it. It's here in this directory, and we are going to take a look at one definition. Let's see which one. Let's do the database first, right? So this is the interface that your users would see, and they would not need to worry about everything required for a database. This is the API you create, right? It can be anything you want. In my case, people can select the version of the database. They can select whether it's small, big, or large, whatever that means, wherever that means, the region they want, how many databases in that server, and they can use, in this case, it's going to be Postgres in AWS, right? Extremely easy, no-brainer. And if you take a look at, and by the way, when I executed that script at the very beginning, I just applied that definition to save a bit of time. And if you take a look at the claim, what is it, silly demo DB, you will see that If it works, it's running. It is creating the database right now. And that database is complex, right? It has all the shenanigans you might need in AWS. There is Atlas for managing schema. There is a bunch of other things. All those things are happening in background, and all those things became possible through basically this definition that the hypothetical developer created. Now, let's do one more. Apps, silly demo. There we go. This is an application, right? It's a different API that developers can use to deploy their applications without having to worry about what's happening in Kubernetes, what's or not. There is an image, there is a tag. Tag is intentionally fixed because I did not build an image yet. Port, host, ingress. I want to connect to that database that I created earlier, right? So I'm here specifying the name of the database, and that's about it. And if we take a look at kubectl namespace, previously I looked at what's happening in AWS. Now we're going to look at what's happening in the cluster, and there we go. It's almost running. The only problem is that the image is not there. It's not there because I didn't build it yet. We'll get there soon. I'm almost done. Almost done. I'm going to delete it. We're going to start over because there are quite a few things that we need to do. So I'm going to production, delete. What's the name? File name is apps. Silly demo. No, when deleting up times the. Thank you, whomever you are.
Get closer to the
There
mic.
we go. Git add. I don't know what you're telling. Mike. Yes. I don't know how to do this. Commit something and push and back. Okay. Next choice. No time to lose. No, that's luck. Here we go.
Here we go. All right, crossplane we have. Now we're going to talk about admission controller policy, and we're going to talk about validating admission policy, which is in Kubernetes, and we're going to talk about Kyverno. So now our developers, they can apply a YAML and they can get a Google Cloud cluster. Amazing. What happens either with mistake or malice? What if they ask for a cluster that's 300 nodes? We need to protect against things that we don't want to happen in our cluster. So if this happens, then we can, and we're using validating admission policy, then that's built into the Kubernetes API. You can use validating admission policy to write your policy, and it'll be like, no, can't do that, and shoot it right back, hopefully with a helpful message. If you're using Kyverno, the process is a little more complex. You're adding configuration to your Kubernetes API server in the form of an admission controller webhook. So then when we try to apply that YAML, it says, oh, anything that has to do with this, I'm sending this decision to Kyverno. And Kyverno is going to say yes or no. They're going to return the answer, and then the helpful message and no way is returning back to the developers. So this is just the very tippy top of the iceberg for what you can do with policy. But basically, you can apply so many rules and guardrails about like what only pull from our internal registry. Don't use outdated dependencies. A bajillion things. And so why would you use one versus the other? I'm going to insert an opinion here. You should use validating admission policy because you already have validating admission policy. And you write your policy with a language called CEL, Common Expression Language. It's a pretty easy language to use. It's lightweight. It's Turing complete, so it doesn't leave you susceptible to a DDoS attack. And you got it, so use it. Now, there's a good chance that eventually you're going to want some more full features, and that's when you want to use Kyverno. Kyverno also does mutating admission policy, where you can change a resource before it gets applied, although that is coming to Kubernetes here pretty soon, I think. But you can generate resources, you can do resource cleanup, you can generate policy reports, you can have access control over who can view what policy reports. So lots of cool things with Kyverno as you mature and what you need. And so there it is. Let's vote. What do you want to see Viktor implement right now?
No time to lose. Fast. Go.
Oh.
One more. Okay.
No, wait. There are 10
5,
people have voted.
4. You two over there. Kyverno. Come on. No?
No. All right. Validating admission policy.
Validating admission policies. Okay. Let's do this. I'm going to install a couple of things through a script, mostly because oh, I have alarm that I should wake up. Cool. I'm going to install validating emission policy. Actually, I created a couple of policies. There is nothing to install; it's already in the cluster, and I'm going to show you the policy that I created, and that's this one for crossplane, right? So basically, this simple one says, hey, if you create or update something called up claims on that API, scaling field should have some value, and then enabled in scaling should have some value, and it should be true. So scaling must be enabled, and the min number, the minimum number of replicas must be greater than one. Very easy, right? So enabled scaling, you must have more than one replica, and that's about it. And now if I apply the same thing that I did before, actually you haven't seen production, apply, file name is CNCF demo app, and apps, and which one is it? Demo here, right? If I apply my application, just as I did before, the message I'm getting, and this is my interpretation coming from a different culture, Viktor, you're an idiot. You must enable the scaling, right? And then I can go and now I'm educated. Now I know what I'm allowed and what I'm not allowed to do. So I'm going to say here, modify manifest, scaling, enabled, true, cool. If I apply it again, then something else happened. Viktor, you're still an imbecile. You must have minimum number of replicas set to greater than 1. And that means that I need to modify it again. Min, let's say 3, right? I apply my application, now it's working. Now everything is happening and so on and so forth. And did I forget something else? Yeah, let me just go quickly there and push the changes. We'll need them later. Git add, git commit, git push, go back. Cool. Next one.
Next one. All right, we're going to talk about one-time tasks. We're going to talk about Argo workflows versus Tecton. So if we're platform engineers, we want to make our developers' lives easier, and part of our developers' lives has to do with their CI/CD pipeline. So testing their code, building a container image, pushing that image to a registry, updating application configuration, testing that configuration, pushing that to a Git repository to trigger GitOps. And so all of that together is called a pipeline. And how can we help developers as platform engineers create and manage their pipelines? So for one thing, we can give our engineers templates to use. So we give them a template. It already has company's best practices. They can extend it for their use case. And again, it has our company specific security and compliance wrapped into it, so developers don't have to think about it. So that's level 1. Level 2 is for us to provide the infrastructure to run that pipeline and to install and manage the tools that run that pipeline. And that's where Argo workflows and Tecton come in. So maybe our developers, they define their pipeline, they apply that pipeline definition to the cluster, and then nothing happens because we're not managing state here. This is a one-time action, and it's probably going to get triggered by something, probably by pushing code to a repository. So then once it gets triggered, then all the infrastructure runs, the pipeline runs, and then when it's done, it all goes away. And that's that. So let's talk about Tecton versus Argo workflows. Tecton is designed for exactly this use case, where one task leads to one task, leads to one task, leads to one task. CI/CD, Tecton is made for this, and it's Kubernetes native. It does other things. You can lead to multiple tasks. You can do conditionals and for loops, but that came later. Argo workflows is designed from the ground up for more complex workflows, but like way more complex, like AI ML workloads, where it's even called a DAG now, a directed acyclic graph, as opposed to being called a pipeline, where one task leads to many tasks, which each of those lead to many tasks, lead to many tasks. So again, just like with Crossplane and Kubevela, this is a lot more powerful, but it's also a lot more complex to use. And then Tecton is your tried and true CI/CD friend. And what would you like to see demoed today?
Okay, 5, 4, 3, 2, 1. Okay,
Argo workflows it is.
Cool. Actually, before I set up Argo workflows, I'm going to install set up a few things for Argo CD. It will become apparent later. What's happening here? Why? Okay. So that's that. Now let's talk about our setup workflows. Argo workflows. There we go. Script. Not much happening over there. Let me show you a simple workflow over here. This is basically YAML, right? You just define, hey, git check out, execute this, execute that. Use scanning code to build an image. You do the stuff as you would normally do just in YAML, and just run your scripts, right? So let's see it in action. Argo submit. No. Argo submit. There we go. Now what is going to happen now is that it will check out the code, it will generate the tag, it will build the image, it will run the tests, it will finally at one moment at the very end, it will modify the manifest, it will push it to Git, because executing kubectl apply should be legal, and eventually Argo CD will pick it up and synchronize it into the cluster. Now this will take some time, so I'm not going to wait for this. Let's go to the next choice. Just to save some time while this is happening. No, this is not the next choice. Admin 1, 2, 3. Yeah, cool. No, where is Whitney? Whitney, where are you? Here, there we go.
All right, the final choice, we're going to talk about GUIs, graphical user interface, or portals. So we're going to talk about Backstage versus Port. So why do we need a portal? We have this awesome API. A developer team can deploy stuff to the cluster. What happens when this scales? When we make lots of capabilities and we provide them to lots of teams? That's when a graphical user interface could really help, because it gets very complex under the hood. So we have developers who don't know what's available to them. How do they know what they can get? And then our platform team too needs a single pane of glass view of everything that's happening. So with a GUI, our developers have a single place they can go to. They can look at a service catalog, see everything that's available. They can get extra education around any particular capability. They can see what they've made and maybe when it expires. And sometimes they can even interact directly with that web interface to get what they need. And similarly, our platform team can also see what's going on through a GUI. Now, a GUI is really, it's a read only from the Kubernetes API server. So you can build a platform without having a graphical user interface or a portal at all. So go ahead. So you can do that with the CLI if you want it, but Portal is a handy tool to have. So Backstage is very, 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 very popular. I think it's second behind Kubernetes in terms of number of commits. And so it has tremendous community support, and it's complex to use because you have to know TypeScript. But there are a lot of plugins available. The what's horrible?
It's not complex. That's understatement.
Complex is an understatement, says Victor. Port offers a low-code, no-code approach to get started building an API, but a GUI, but it is a commercial. It's not open source. What would you like to see? And then
Quick.
telling
We
us
have
to hurry in the background.
minus 3 minutes left there.
2 minutes.
5, 4, 3, 2, 1. Okay.
Back.
What was it?
It was technically port in the very last second, but it doesn't matter because we're only demoing CNCF stuff.
Yeah, so
we were always only going to demo. That choice was a lie.
This is still building from before, so it will probably won't have enough time to wait for it. So if this finished building and Argo CD deployed it, you would see it here, just as I'm seeing something. The first one I deployed earlier. You can explore it. You can see what's the details. You can see the graph. There we go. All the resources. You can do all the cool things. But what is more important or cooler is that I'm using a plugin in Backstage that basically goes to the cluster, discovers, nothing is hard-coded here, right? Discovers what are the available APIs, brings back to me, and then I can do the same thing that I did before through graphical user interfaces. So I can say, hey, I want an application, cool. This is all dynamic, nothing hard-coded. I'm going to name it this is the namespace, this is the owner, next. And when you come to the end, it will not do anything in a cluster because, as I said before, it should be legal. It will update or create a manifest, push it to Git, Argo CD synchronizes it into a cluster, and we leave. No, sorry. The pipeline builds the image.
There you go.
Then it gets synchronized into a cluster, and we live happily ever after. That's it.
That's it. Last slide. We're
Last slide. There is more slides. Okay, there we go.
just the last.
There we go.
Look at that. Now we have closure. This is to see our streaming show. That's a link to our streaming show if you want to watch that. I also have You Choose stickers here up front. And thank you so much for hanging out with us. This was fun.
This is such a special event for us. This is the first time that the demo worked. First time.